Derek, Dwayne,
Here.
Angel, Gavin, Bailey, Kaylin, all right, don't tell her stories. Abigail, Alyssa, Alicia, Michael, Ricky, Desmond, Sanaya. All right, it is on number 4. When it gets back to 4, we are ready to roll, so I need you on task for me.
Make sure you go ahead and take care of your phones. Either plug them in the charging station, in your book bag, not in your pockets, not in your desk.
All right, if there's one you did not see, ask me specifically. Which one? 5. Okay. What else? Are you good? Well, I should not hear this. I didn't get to that one, or I didn't do that one.
Do you have a negative exponent? What does that negative exponent tell you to do? Take the negative away.
Good to go? Okay, everybody good? 4? Sure. Oh, all right. All right, here we go.
Angel.
All right, Angel, what you got on number 1, my friend? What type of an exponent do you have there, Angel? You do. You got a negative, okay?
What's that tell us to do?
Tells you to do something with your base. You can tell her the math term we use. Refresh your memory. The math term we use. Find the, I heard it back there, reciprocal of your base, which means exactly what you just said. What did you just say? Just flip it. Yeah. So the reciprocal of our base. So if I flip that base, Angel, 1/5 becomes what? 5/1. Okay. And when I do that, then that negative exponent becomes a positive exponent. So 5/1 is the same thing as what? as 5, that's exactly right. So now I got 5 to the positive 2 power. So 5 to the second power would be 5 times 5, which is, there you go.
Whenever we told you, whenever you have a negative exponent, it's like a negative attitude. It can't stay there. It's gotta go somewhere. Well, if it's on the top, where's it gonna go? To the bottom. If it's on the bottom, I'll let you know in a second. If it's on the bottom, where's it gonna go? To the top. That's why we do the reciprocal. That's why we flip it. And that 2 goes with both parts. So after you flip it, it's 5 over 1. 5 squared is 25. 1 squared is 1. 25 over 1 is still 25. Now what was your question? This negative right here just tells you to flip that upside down. And then anything over 1 is always itself.
Good? All right, Bo, talk to me about number 2. What you got? I got negative 75 too. Nice job.
Bailey.
Bailey, can you help me out on number 3? 10.5. Very good. I thought of money there. Okay.
Desmond.
Desmond, how about number 4? What you got?
11,
I like that.
It says 2
I
square
like
roots
that.
though. That's only 1.
negative 11,
Oh, very good.
Awesome
Because
job.
Desmond, what is 11 times 11? 121. What is negative 11 times negative 11? Positive 121. Remember, negative times negative is positive. So they're going to do that to you. If they're asking you in the radical symbol, they only want the principal square root, which is the positive one. But if they're asking you in words right there, they're wanting both of them. If they're asking you for the 2 square roots. So just remember that.
Helen. Jordan.
Jordan, what you got on number 5?
What's that negative exponent tell you to do? It's like a negative attitude. It can't stay there. So where's it going to go? We're going to do the reciprocal. We're going to flip it. So it's going to be
1 over
1 over 1 over h to the 6th. I heard it over there. I think it was
1
down
over
there.
h to the 6. It can't be h to the 6 because that way all we did was just take away that negative exponent. We haven't justified doing that mathematically. We got to find the reciprocal of the base in order to prove that that is a mathematical way to get rid of that negative exponent, okay?
Dannon.
Dannon, what about number 6? You got what? I got 11 also, very good. Square root of 144 was what? And then subtracting the square root of 1, which is what? 1. 12 minus 1 is, good job. All right, number 7, Ricky, what you got? Say it again. I'm on 7.
I saw it like.
Well, look at it. Combine your like terms. They all have x's, so all you have to do is deal with the numbers. 10 what?
10x, very good. I looked at this right here and I saw a positive 5x there and I saw a negative 5x there. What happens with those two?
They cancel
Zero
out.
pair, they cancel each other out. That's exactly right. The only thing left is that 10x.
Gabe.
Gavin, talk to me about number, what are we on? Number 8.
What do we do with exponents on a power to a power? Do we add them? Do we subtract them? Do we multiply them? What do we do? Multiply them. What is 7 times 5? 35. So that our final answer is going to be y to the 35th.
Very
Good.
Y to the 35th.
Wayne.
Lowain, talk to me on number 9, my friend.
negative 26,
Say it again.
negative 26,
I got something a little bit different. Look
Same
at it.
teams or different teams? Do what? We've got a
Yes.
negative 20. Do you see a negative in front of the 6? Okay, so are they on the same teams or different?
different,
And whenever they're on different, we have to do what? They're gonna cancel each other out. So those 6 are gonna take 6 away from that negative. So 20 minus 6 is 14. And which team had more? The positives or the negatives?
negative,
So it's negative 14.
Very good. All right.
Alyssa.
How about Alyssa on number 9? No, I mean number 10, please. Could you?
Okay, let's look at it.
Only answer we don't accept is I didn't get that. We're gonna try it, okay?
45 divided by 9 is 5. And then what do we do when we divide, what do we do to the exponents when we're dividing? So what is 8 minus 5? So it's, what'd you get here, 5, h to the 3rd.
Okay? Ask questions, okay? Don't skip them. We don't want anybody skipping problems because these are your review, okay, for everything that we've already covered. All right. Somebody tell me what we did yesterday. Okay. So we focused on our new unit, which is what? Relations and functions. Tell me what a relation is. Somebody tell me what a relation is. Beautiful. A set of ordered pairs. Somebody tell me what a function is. Somebody tell me when we're having a vocabulary quiz. This Friday. This Friday. On what? The 20 that you have on there, okay? So we went over every one of them yesterday, so you should be very, very familiar with them. And they are the key to your foundation for this unit, okay? So we are going to review a little bit today before we start kicking it into the higher gear of the new stuff. We want to make sure that your foundation is strong enough for us to build that algebra part on. So a lot of this stuff is going to be repetitive that you saw last year, or I'm hoping you saw last year and you remember it, right? Okay, and here we go, here we go.
All right, so yesterday we went over all of your vocabulary. I got the wrong one, didn't I? Yesterday we went over your vocabulary, and a lot of this stuff was already on there and it was already familiar to you. So the first thing we're going to look at is your coordinate plane. Now, who can remember what our definition for coordinate plane was yesterday? Or you can kind of tell me about it a little bit.
I'd keep that vocabulary list out and have it handy today.
It does have a horizontal and vertical axis, and those were called the x-axis and y-axis. I agree with that. And we already know it's a plane. What did that y-axis and that x-axis do to my plane? It separated it into 4 regions, and those 4 regions are called what? Quadrants. Good. So for our definition of coordinate plane, we had this yesterday. We're just keeping it fresh on our mind. It's a plane divided into 4, you can say regions here, you can say quadrants, whatever it is that, I'm going to use quadrants just because that was one of our vocabulary words from yesterday, just so we can keep it fresh on our mind. And what do we use this for? What do we use a coordinate plane for?
Heard somebody say it.
To graph, I heard it. Used for graphing. So it's a plane divided into 4 quadrants, and we use it for graphing. The next part says label the origin, the quadrant, and the x and y axis. Who can kind of tell me about my origin? That's the first thing on the list. Shannon, what's the origin? It's in the very middle, and what did we say its address always is? 0, 0. So my origin is at 0, 0. And what's special about that origin? It's not negative or positive, and it's always where we start whenever we're graphing. You always go back to the origin. Alright? We just said a minute ago that it's divided into 4 quadrants. So that's this square, this square, this square, and this square. And they're numbered 1 through 4. Who remembers the trick we told you yesterday to remember your quadrants? Do what now? It goes counterclockwise, absolutely.
Make it a C.
Make it a C. If you're going to write the letter C, so I started up here, so this has to be quadrant 1. And then I came this way, it's going counterclockwise. So this is quadrant 2. That makes this quadrant 3. It was the next one I got to. And that makes this one quadrant 4. And they're in Roman numerals.
Why,
Right.
we don't know. That just is. They didn't ask our opinion whether we wanted it to be Roman numerals or not. We have to follow the lead.
So there are quadrants, 1, 2, 3, and 4, and you can remember that by writing that capital C for that coordinate plane. All right, now our X and Y axis. One of them is horizontal and one of them is vertical. Question is, which one is which? X is horizontal, absolutely, and Y is our vertical. So we have labeled our origin, our quadrants, our X, and our Y axis. Alright, next is ordered pair. All of this again should be just be review from middle school. We're just making sure it's fresh on our mind. So what's an ordered pair? I know y'all know this, y'all are just quiet this morning. That's right, it's a point. And it's written as X and Y on the
Does it
graph.
matter the order? What if I want to put the Y first? So no? Okay. What if I get confused as to which one of them goes first? How can I remember that?
X, which one comes first in the alphabet?
Oh, alphabetically, very good.
What other vocabulary words that we learned yesterday that went along with X and Y were also in alphabetical order? Domain and range,
Very
good. Domain, the D in domain comes first, so it goes along with our X. Our range comes after domain, and it comes second, so it goes along with our Y. We'll get to that more in a little bit. Alright, so now, just practice naming. It says identify the ordered pair and the quadrants for each point. So we've got this that we can look back at for our quadrants. If you want to, this is pure personal preference. If you want to, you can sit here and make yourself a little note for each one, but you don't have to. Up to you. Whatever you're most comfortable with. So, point A is right here. Whenever I'm finding this, where do I always have to go back to start? The origin, which is right here, and that's point 0, 0. So now, do I go left and right first, or do I go up and down first? Left and right. If I go to the right, that number is positive, and if I go to the left, that number is negative. If you don't remember that, make yourself a little note. This is negative, this is positive. Alright, and now my up and down. If I go up, it's going to be positive, and if I go down, it's going to be negative. If you have a tough time remembering that, jot yourself some little notes on there. So if I start at the origin, I'm going to have to go left to get to A. How many points is that? Negative 3. I agree with that absolutely. So that is negative 3. And then I have to go up. How many? 4. And up is positive. So there's my ordered pair. And what quadrant is A in? Quadrant 2.
One thing I like to say when I'm plotting points, plotting order pairs right there, is run before you jump. So you're going to run to the right if it's positive, run to the left if it's negative, but you're going to jump up. If it's positive, jump down if it's negative, but you always run before you jump.
Alright, who knows what the ordered pair for B would be? 2.
And down.
So positive 2, negative 3. And what quadrant is that? 4.
What do we
Good.
know about all ordered pair in quadrant 4?
Let's go back up here to this right here. To get to quadrant 4, I start at my origin, I'm going to the right.
The first number going always be positive.
Very
So that's
good.
positive. And then the second number is going to be down, so it is,
Negative.
so this one is positive followed by negative. What about quadrant 1? What are we going to have? To the right gives me a positive, and up gives me a positive. So it's going to be positive, positive. Quadrant 2 is going to give me a negative and a negative and a positive. And quadrant 4 is going to give me a negative and a negative.
Now, as simple as that was, folks, I am telling you, on a standardized test or any multiple choice test, knowing that will help you eliminate wrong answers. You know that your answer is in quadrant 3, and 3 of your answers have positives in it, then you know what? There's your help right there, your kind of cheat sheet right there.
It's your test-taking strategy. All right, what about C? I didn't have to go left or right at all, so what is that going to give you? 0. I have to run before I jump, remember? So 0, and then up 2 is a positive 2. Quadrant. What are we going to say for a quadrant?
Well, it's going to be quadrant 1 because it's positive.
0 is neither positive or negative. 0 is neutral.
So is it in quadrant 1?
It won't be one?
Is it in quadrant 2?
No.
It's on the line.
It's just on what line?
On the edge.
It's on the y-axis.
So instead of a quadrant, you can't identify a quadrant, can you? So you just say that that one is on the y-axis. Good.
All right, what's my coordinate for D? 7, 1. I agree with that. Good. And that quadrant is? Quadrant 1.
X and Y are positive.
All right, what about point E? I heard -4 what? -4, -6. And that is quadrant 3.
Where both X and Y value are both negative.
And letter F, last one. -5, and then I have to go up or down. So that's a 0. What quadrant? It's on the x-axis. It's not in either quadrant. All right, who remembers what a discrete graph was yesterday? This right here is a discrete graph. It's a graph that just has points on it. We're just going to put a graph of distinct, because we know exactly where they are, points.
What is not happening with those different order pairs? What are we not doing? We're not connecting over the line. That's exactly right.
And this over here is just for an example, and no rhyme or reason. We're just going to put our dots on there, scattered around. No connections, just dots. So if a distinct graph was a graph, or a discrete graph, I'm sorry, was a graph with just points on it, what's a continuous graph?
It's got it connect.
The dots are connected. It's either got a straight line or it's got a curve on there connecting those dots. So it is a graph with connected lines and curves.
Your 8th grade graphing, you stuck with linear as a straight line. So we are still going to do quite a few linear, but we're going to also branch out into nonlinear. We're going to have parabolas with our quadratics, and we're going to have exponential functions as well. So we are using what you already have and building on it, going beyond.
So I'm just going to draw some points on here, and then I'm just going to connect the dots. Doesn't have to be the same shape as mine. Just draw you some points and connect your dots. You can do a straight line if you want to. I think we did that example yesterday. So I tried to put you a curved example on here today, just so you have multiple examples of the same thing with different options on there. All right, questions about any of those? Should just be review. We've already covered a lot of this. All right, flip over to the other side, to our relations. Now, all of this stuff has to do with trying to figure out if it's a function. We did our domains and our ranges. Y'all just told me a minute ago, domain is another word for what? Your x's. And range is just another word for your y's. So this shouldn't be very difficult here. Now, what is it? All of these individual little parts right here are called what? What is negative 3 and 1? What is negative 2 and 0? All of those are called what? Ordered pairs. And now a group of ordered pairs, all of these ordered pairs together are called a what?
Talked about it yesterday. Heard it over here.
Relation. That's what our topic is up here. A relation. So this group of all of these different ordered pairs are called a relation. Alright, so using our ordered pairs, y'all just told me my domain was my x's. So what's my x in my first ordered pair? Negative 3. Write it down. Alright, what's my x in my next ordered pair? Negative 2. My x in the next one is 1, then 3. Do I have to put that last negative 3 since I've already got a negative 3 one time? No, I don't have to repeat it. So that's it. And here comes our little fancy squiggly parentheses or brackets or whatever you want to call them around it. Alright, so since I did all of my x's first, and I'm just going to circle all my x's, just for the simple fact of not looking at those numbers again, canceling them back off. Now what are my y's? 1, 0, 2, negative 4, and 5. But what did we say was special about these yesterday?
They can't.
They've got to be in what?
Oh, they gotta be in order. Oh, they gotta be in order.
They've got to be in order from least to greatest. Now this one just so happened to be that they were already in order from least to greatest. But this one right here on my y's, I've got to go back and do a little rearrangement. So my smallest is negative 4. That takes care of this one.
0.
And then 0. And then 1,
2, 5.
2, and 5. Put my little fancy brackets around them. And now my domains are going to go straight down my table. I had negative 3, and what was negative 3 paired with? 1. What was negative 2 paired with? 0. What was 1 paired with? 2. What was 3 paired with? Negative 4. And what was negative 3 paired with? 5. Alright, and now to practice our mapping, we're going to use our domain and our range right here that we just did. So, for R, we're going to call this our domain. I'm just going to keep them separate. I'm going to put my D up there for my domain and my R up there for my range. And I'm going to use the domain and range over here to fill these in, because our mapping, we also don't want what? Repeats. And over here, we did not write repeats. Here we did, because we had to fill in all of the points. So I have my negative 3 on there twice. So I want to use this list that does not have my repeats to fill in my mapping. So I have, and again, it's the same way. It has to be in order from least to greatest. So I have negative 3, negative 2, 1, and 3. I have negative 4, 0, 1, 2, and 5. And I'm done with that, right?
No, we got it.
That's the most common mistake we see. You fill in the circles and you stop. What do I have to do? I have to connect them. How do I connect them? Just whatever I want to?
No,
with the
but
pair,
on
with
the
the
pair.
pair.
With the pair. So this is where I'm going to use my table. My negative 3 paired with 1. So I'm going to connect those. My negative 2 paired with 0. My 1 is going to pair with my 2. My 3 is gonna pair with my -4. And my -3, back up here at the top again, is gonna come down here and pair with my 5.
What can you tell from that mapping right there?
That's good, it's not a function.
Okay.
Why is it not a function? Because x's can't cheat. This x is with our 1, and this x is also with 5. So this one will not be a function. And we'll be able to use, what was our test for a picture that we said we could use to see if it passed? Vertical line test. We're going to be able to see in just a second, because now I have to plot all of these points on my graph. Y'all are familiar with that, so y'all go ahead and get started on that, and then you can look up here to check. And there's no letters to put with them. You don't have to put A with 1 and B with 1. You just plot the points. Remember, x's, if you need to keep this from the other side, x's is your horizontal, right is positive, left is negative. Y is your vertical, up is positive, down is negative. X comes first, your Y comes second. X goes side to side, Y goes up and down. If any of this helps you, absolutely write it down, steal it. Use it for yourself. If any of that helps you. What type of graph is this? Discrete. Why is it discrete? It's not connected. Good. And we can use now our vertical line test to see if we hit 2 points anywhere at the same time. Right here, I'm going to hit 2 points at the same time. So that tells me, just like this mapping told me this is not a function, my vertical line test right here, when I hit these 2 points at the same time, tell me this is not a function. All right? What's my domain on number 2? And they are already in least to greatest order, so I can just write them down. -2, -1, 0, 2, and 5. No repeats in there to worry about. All right, what's my range? Who can go ahead and look at them and tell me in order what my range is? So we had -4, -3, -2, -1, and 4. Are we going too fast for anybody? We're all okay? Okay. And now these points right here, they just gave us in our ordered pairs. We now have to fill in our table. So I had -2 with 3, -1 with 4, 0 with -2, 2 with -4, and 5 with -1. Now, is it going to be better to use my table or better to use my domain and range to fill in my mapping? My domain and range. Because it's already in order least to greatest, and my mapping has to be in order from least to greatest. So -2, -1, 0, 2, and 5. -4, -3, -2, -1, and 4. And how do I know which ones to connect to? The ordered pair. So -2 is going to connect with.
That
Did I
should be
leave that
negative.
off?
Yeah, that's
Yep,
negative.
I left that
right.
off. -3 right there. -2 is gonna connect with -3. I knew something didn't look right. I didn't see a -3 over there, or a +3 over there. All right, -1 connects with 4. 0 connects with -2. 2 connects with -4. And 5 connects with -1. Did any of my x's cheat? So what does that tell me? This is going to be a function. You can tell from your table right here, no x's repeat. It's going to be a function. You can tell from your mapping right here, no x's have 2 lines coming off of it. It's going to be a function. And then after we graph it, y'all can go ahead and get started graphing it. We can use our vertical line test and we're going to see this is a function. All 3 of these, along with my ordered pairs up here in my list, all can tell me this is or is not a function. You now know how to identify it 4 different ways. Remember, x, if it's to the if it's a negative, it goes left. If it's positive, it goes right. That meaning, y, if it's negative, it goes down. If it's positive, it goes up. So when I graph it, I say left 2, down 3. Start at my origin, left 2, down 3. Left 1, up 4. Left 1, up 4. Don't move, so 0, down 2. I talk myself through it as I go. You go ahead and try number 3. I'm going to give y'all a second to get started, and then I'm going to start filling it in up here. So if you get stuck, you can either raise your hand, or you can glance up here and see if you've got what I've got.
Oh, you gotta go with the dots. Oh, you gotta get
Oh yeah, this one right here didn't give us our ordered pairs. So what do we have to do first?
You gotta go with the dots.
You got to use your graph. They already filled in our graph. We can get our ordered pairs from our dots. I'll get that part started for you at least. Alright, so I'm going to start on the right and I'm going to work my way to the left. So this dot right here is positive 1, 2, 3, 4, positive 2. So I have 4, 2. Alright. This one right here is next in line, so that is positive 1, 2, negative 1, 2, 3, 4, 5. Positive 2, negative 5. Alright, this one I didn't go left or right, so that's 0, and I went down 1, 2, 3. So that is 0, 3. This one is next. 1, 2, left 2, up 1, 2, 3. So that's negative 2, positive 3. And then left, so negative 1, 2, 3, 4, 5, down 1, 2, 3, 4. So that's negative 5, negative 4. Okay, now y'all get a head start. Some of you I see's already done it. That's great. I'll give you a head start, and then I'll catch up. You can check your work with mine, make sure you've got it. Yes, order matters, so make sure yours is exactly like mine. Unless I make a mistake, and then y'all absolutely call me out on it. because I will make mistakes. And if you can catch my mistakes, that's telling me you're paying attention and you know what you're doing. So I am absolutely good with that. All right. Does anybody have questions or stuck somewhere and you're not sure where you're stuck at or why? The other thing we were going to try to get to today, which we've been talking about it all along, so we have kind of got to it today, is this going to be a function?
No.
Why?
Well, yes it is, because there's no,
Are any x's repeating?
no.
No x's are repeating, so is it a function?
Yes,
How can you tell?
because the line.
Okay, we have a line test over here.
Yes.
If I use my vertical line test,
Anybody bring their vertical line with them today? There you go.
did I hit any 2 points at the same time?
No.
No. So it passed my vertical line test. That's one way. What's another way you can tell? Any x's right here, or any x's repeating?
No.
No. How else can we tell? From our map, does any of my x's have 2 lines coming off of it?
No.
Can a y have 2 lines coming off of it? Yes. If a y has 2 lines coming off of it, is it still a function?
Yes.
Yes, good deal. All right, we're going to stop there today. Y'all basically already hit functions as well, so we'll probably hit that pretty quick tomorrow, and we'll move on. Good job today, though. You got your phones plugged in, come get them. And y'all can go ahead and start packing up.